Hello, on this podcast, we are going to work a few distance equals rate times time problems. Now, remember, a few weeks ago, we worked pre-algebraic equations where we were solving for x. So that means that if we were saying that x equals 3 times 2, then x equals 6. On the other hand, if we said that 6 equals 3 times x, then that meant 6 equals 3x. And to eliminate or isolate the variable, we had to divide both sides by the number that was with the variable in this case. And the reason that we chose division was because this says 3 times x. So we do the opposite. In this case, we divide both sides by 3. On this side, we are left with 2 equals, this cancels out, and we are left with a 6, or with a x. Okay, so we're kind of going to apply the same principles in the distance equals rate times time formulas as we did in the pre-algebraic equations. So let's just start with the easiest ones. If we have distance equals rate times time, and they say that the rate is 50 miles per hour, and if they say that the time is 2 hours, the good thing is that there's no conversions that we have to work. We're just simply going to plug it into our distance equals rate times time equation. So we're just going to plug in what we know. So the rate is 50. We are multiplying that, and the time is 2. So we're just plugging that into the equation. In this case, distance equals 50 times 2, which is 100. And our process of elimination, we have miles per hour over hours, technically. Those cancel out, and we're left with d equals 100 miles. Right now at this point, though, you may not recognize that. So what I would suggest is when you're trying to figure out what unit you should be using, distance, clearly, if you think about it and you say, for distance, am I going to use miles? Am I going to use hours? Or I'm going to use miles per hour? Well, clearly, miles per hour is going to be your rate. Time is going to be just the hours. So that means that the distance is going to be miles. Or you can look at it as I am going to cancel out my like terms, and whatever I'm left with is what I'm going to be using in the end. Okay, so just another example. Distance equals rate times time. If the distance they do not give you, you can give it a variable. If you want to assign it an x, you can. But I really wouldn't worry about that so much. But if you would like to, you're more than welcome to assign that an x. Let's say that they give you a rate of 30 kilometers per hour and a time of 4 hours. Again, because we have hours and hours, we don't have to do any conversions beforehand. We can just simply solve. So d equals rate times time, which is 4. X equals 120. And again, you can just x out your like terms. You're left with kilometers. So that's what you're going to use. Okay, those are the easy distance equals rate times time problems. Let's work in a couple of harder ones. Now, they're not always going to make it as simple as giving you the rate and the time and having you solve for distance. In other times, they're going to give you the distance and they're going to have you solve for either the rate or the time, giving you the other one. So, let's just do an example of that. Writing down what we know, distance equals 400 miles. The rate, in this case, is 40 miles per hour. And I have to find the time. So I'm just going to assign it a variable because I actually have to work an equation or a formula out for this. Okay? So now I'm just going to plug in everything that I know through here. Distance equals rate times time. Distance is 400. Rate is 40. Times I assigned t and x. So now I can simplify. 400 equals 40x. Okay, in the basic examples that I gave you earlier when we started this screencast was that now what we have to do is we have to isolate the variable, which means that I'm going to end up with an x on one side and a number on the other. So this says 40 times x, and to get rid of what is with the variable, I have to do the opposite of what it says. So this says to multiply, so I'm going to divide both sides by 40. If I do that, my 40 divided by 40 is going to give me 1. So we kind of call it canceling out. 400 divided by 40 is 10. So in this case, x equals 10. Well, x is a time unit. So let's just look at what we have. We have miles and miles here. So we're left with hours. So 10 hours is how long it took. Okay. Let's look at one more problem. In this case, I'll give you the distance and the time, and you have to find the rate. So distance equals rate times time. Or you can say d equals rt. Same thing, just depending upon the level. In this case, the distance is 315 miles. The rate we don't know, so we're going to assign it an x. And the time we're going to say is 3 hours. Okay, so we just need to find the rate. So already we know that our rate is going to be miles per, you can say it two different ways. You can say miles, miles per hour, or you can say miles per hour. The reason that you would include the I here is because in scientific terms, M normally means meters and MI means miles. So let's just plug this in and get to work. 315 equals x times 3. Let's rewrite that in our proper manner of 315 equals 3x. And now in this case, we want to isolate the variable. We want the x to be by itself and the y, or the numbers, to be on the other side. To do that, I have to perform the opposite of this operation that's with my variable. That says 3 times x, so I'm going to divide both sides by 3 to isolate that x. In this case, 315 divided by 3. I'm going to use a little bit of workspace to solve this. Whoops. Three cannot go into 1, but it can go into 15 5 times. So x equals 15. Okay, to check it, I'd just plug that back in. So 15 times 3 is, 105. Okay, 105 times 3. Okay. 1 and 3. Okay, so you get what you started with and you are finished. Okay, so those are distance equals rate times time problems. If you have any questions, you can email me some specific examples and I'd be more than happy to help. Thank you.